Okay, so Unit 3 is a bit of an odd one, okay? And it is set theory, okay? So what this is all about is how data is kind of organized. Yeah, that was it. So, when I say set theory, when I'm talking about a set, it's a collection of data, okay? Can you guys turn that off, please? That's kind of a distraction. Thank you. Okay. And we call the data a collection of data. A single piece of that data would be an element. Okay. All right. Just so everyone knows. It's a little more all over the place. Like we'll get into some probability. Yeah. Yeah. An element, I guess it should be. No. But there are some symbols and stuff and notation that we gotta learn. So, now, there can be subsets, okay? So a subset this is a smaller collection of data within a set. Yeah. Okay. So, for example, let's say a set of data could be all the provinces in Canada. Okay. There's like what? More than I know there's 10. I was gonna make a joke about too many to count, but there's only 10. So the whole set would be all 10. The 10 would be what? Close. Well, it could be, or like say like the prairies, or the Maritimes, right? Or the cool ones, sure. All right. So the cool ones, everything but Manitoba, I guess. Hey-o. Manitoba burn. No, I'm kidding. New Brunswick would be the non-cool one. We all know it. Whoa, D! It's true, we're pretty lame, let's be real. That's true. Yeah. I know. So, okay, so So there's a couple different ways that we can display a set. So like if we were going to do all the provinces in Canada, there could be set notation. And this is where it looks like. It'd be like P for provinces equals, you do it like this, and then you just list everything inside of it, okay? So like BC, Alberta, Saskatchewan, Manitoba, Ontario, Quebec. Is it QU or QB? Well, I think it's QB. Yeah, the QU looked weird. Quebec, New Brunswick, Nova Scotia, PI. Oh, I got New Brunswick twice. NS, Newfie. I think Newfoundland's just NF. Mm-hmm. Newfoundland. Goofy Newfies. Newfoundland. So you could do it. So this is set notation. You could also do it as a Venn diagram. And then you would just list them. You just write them in. You just write them in. Well, just hold on. Like this would be, um, yeah, it's a Venn diagram. So then what you could do is like put them into subsets. So like you could put a group here. Well, so this would be for provinces. Oh. You know what? Manitoba has the Canadian Mint, which I think is very cool. I would love to go see them make loonies. I think that's the coolest thing. Like the Royal Canadian Mint, where they make all their money. It's in Winnipeg. No, it's in Winnipeg. Yeah. Well, I don't know why is it in Winnipeg. It doesn't make a lot of sense, but it's good. So, but yeah. Otherwise, hey, Cypress Hills, highest highest point in Canada east of the Rockies. Yeah. It's rad in there. Especially yeah, if you go to the West Block. That's I think where most of the equestrian stuff is. Like those conglomerate cliffs. The bomb. Oh yeah? There's a lot of cougars in there. It's like highly dense, a high cougar population. High density of cougar population. Well yeah. They can kill deer. Just hunters. Yeah. So like they'll hunt them. Like if they get into cattle there, they'll get like a team of like dogs and track them and if it's an old cougar, they can usually catch it. But if it's a younger cougar, there's no way they'll catch it. They can lose the dogs like that. They can like lose the dogs and everything. Yeah, they're pretty collected. So, okay, let's get back on topic. So this would be one subset, the prairies. Another subset for the Maritimes. Okay. For provinces. Yeah. The Quebec was. Okay. So, just so you guys know, everything here, like all these provinces, this is known as your universal set. It's all your data. Okay, so we call this universal. And then these here are your subsets. Now see here, like sometimes subsets will have numbers in common or data in common. See how these two subsets have nothing in common? They're not touching or anything like that. They're called disjointed. Because sometimes you can have data that is the same. Let's look at another example. Oh, not this again. Oh, God. Oh. No, he just died. He died like 4 years ago. It is an impressive head of hair. He's got it going on. Okay, so all numbers from 1 to 10. So my... oh. So, oh, you guys, it's a slippery slope. Don't. Of course. Now, so this is my universal set, all my numbers. Now I'm going to make up a couple subsets. Yeah, 1 to 10. Oh, sorry, all numbers from 1 to 10. So I'm going to make up one subset, my even numbers. 2. Then I'm also going to do multiples of 5 as another subset. No. You could, yeah. O could be odd numbers. But you see here now, these two numbers, like these two subsets, E and F, they share common data, right? So these would be considered non-disjointed. So if you were to do a Venn diagram of this, right, one. So here would be even numbers. So, yeah, 10 is an even number. So here are my evens. Yeah, 5 is circled with these ones here, not with the even numbers. Now, Sam brought up a question about the odd numbers. Now, if you notice, like I haven't listed the odds, right? But the odds would be everything that's not an even, right? So odd would be 1. But this shouldn't be earth-shattering news at all, I'm hoping. Listing the odd numbers from 1 to 10. Now you see here how these two sets have absolutely nothing in common. They're the total opposites of one another. So everything that's not in even is an odd, and everything that's not in odd is an even. These two sets are known as complements of one another. Okay. So we call the complements. Here, I'll scroll back up. So sometimes for complement notation, what they'll do is, so this is even numbers. So the complement of the evens we would say is odd, or what you would do is you would put an E with a dash above it. And that stands for the complements of the even. Okay? So it's like not evens. Here, that's an M for multiples of 5. No, they don't have. They're because they've had the opportunity to be vaccinated. There's no mass anymore. There's no more mass anywhere in the province, except in like maybe hospitals or something like that. Yeah, yeah. So we'll see. We made it 2.5 months last time with no mass, so who knows? Well, we had the summer in there. Maybe 2 months. Yeah. Well, no, then like the Delta variant kicked in, and Delta killed a lot of people. Yeah. Omicron is not as severe, although they are seeing quite a few people dying now. But who knows? Yeah. So, anyways, another thing that we do, if you ever see something like this, a little n, and then like I have u here. So this n here means number of elements. Okay? So if we go back to our set here, how many elements are in my universal set here? 1, 2, 3, 4, 5, 6, 7, 8, 10, right? So the answer is 10. Now, how about the number of even numbers? There's 5 even numbers. How many multiples of 5 are there? 2. I asked you how many were multiples. So this here means number of elements. What's that? Yeah, 5 and 10, yeah. Now, the the thing to know about the complements is that if you were to go the number of element non-evens plus the number of evens, it should equal everything, right? Worked. Plus all the evens, it should equal everything. That's how the complement works. So for example, let's say I had a set of 600 numbers, and I knew like my complement was 20. The complement to that would be, 600 minus 20. Bingo bongo. Excellent. Okay. Yeah, for the most part, the test was great. Okay. That's kind of all I have for you guys. You didn't miss a week. It's like all of September, man. You were literally making hay while the sun was shining. Okay, on page 156. That's what happens. Well, some people. I didn't go back to 19. Yeah, no, it can happen. Like, it goes either way. Like, I took 2 years off and went from